So we're going to begin chapter 5.4, which is the definite integral. The definite integral. Let function f be continuous on the closed interval a to b, a is the lower limit, b is the upper limit. The form f of x dx is hold the definite integral. In other words, b and a actual values that will give an answer now instead of abstract functions. I'm going to go ahead and give you 5 properties here. If we're taking the integral between a and a of any function, it's equal to 0. And I mean, to understand what's happening, what this is allowing us to do is to actually find the area under the curve between a and b. That integral area under the curve between a and b is the definite integral. So if we're going from a to a, then there's no area under the curve. We're just talking about a single vertical line at that point. The area between a and b of f of x, or definite integral, is the same as if we reverse the upper and lower limits, it's the negative of that quantity. And it actually comes out precisely when you do it. If there's a constant with the function, you may put that constant outside, and multiply it by the quantity that you find for the definite integral. K is a constant. Between b to a, f of x plus or minus g of x. So two functions either added or subtracted between the two limits. B of a of f of x dx plus or minus b to a of function g of x dx. And this is especially important where you might have a part of the curve, say above or and below the x-axis. And finally, a very important rule: c and a of f of x dx is equal to the integral between a to b f of x dx plus the integral between c to b f of x dx. In other words, if we needed to find between a to c, and this is b, we would take the integral first between a to b, and then add it to the integral between b to c. Okay, so this part here is b to c, and this part is a to b. Many of the solutions for these problems can be found with your calculator. However, this chapter here kind of gives an overview of six very straightforward problems. I'm going to do them for you as examples. Find the area enclosed by 4 non-overlapping rectangles if each rectangle is 7 inches high and 2 inches wide. So this is kind of a straightforward problem. It's giving us the dimensions of this rectangle is 2 and 7. So area of each rectangle is equal to 2 times 7, or 14 square inches. And if the rectangles are not overlapping each other, if we have 4 of these rectangles side by side, then Total area is 4 times 14, which is 56 square inches. Given the integral between 9 and 5 of x dx is equal to 28, the integral between 8 and 5 of x squared dx is equal to 129, and the integral between 9 and 8 x squared dx is equal to 217 over 3. This is some information that we're given, and we're asked to calculate the integral 925 of 9x dx. So the only one of these that we're going to use is this one. So this is 9 integral 925 x dx. And this 925 integral is given as 28. So this is 9 times 28, which is equal to 252. Given the integral between 6 and 1 of x squared dx is equal to 215 over 3, between 7 and 6 x squared dx is equal to 127 over 3, and between 6 and 1 x dx is equal to 35 over 2. Calculate the integral between 6 and 1 of 4x plus x squared dx. So we're going to split this up into two separate integrals based on the rules that we have. Between 6 and 1, 4x dx, plus between 6 and 1 of x squared dx. So this is equal to 4, and then the integral between 6 and 1 is 35 over 2. So 4 times 35 over 2, plus between 6 and 1 x squared is 215 over 3. So this is 70 plus 215 over 3. You can use your calculator to do the fractions, but this 210 over 3 plus 215 over 3, which is equal to 425 over 3. your answer would have to be in the fraction form. Okay, so make sure that you either use your calculator, or if you know how to do fractions, that's fine. You can go ahead and say 210 over 3 plus 215 over 3. In other words, this is 70 over 1 is times 3 times 3. To make the denominator 3 is 210 over 3. All right, next question. Given six one x squared dx is equal to 215 over 3. 7 to 6 x squared dx is equal to 127 over 3, and 6 to 1 x dx is equal to 35 over 2. Calculate the integral between 6 and 1 of I'm sorry, I think I lost my way there. This is still question 3. Yeah, this is question 3 again. So we're on this was question 3. So this is actually question 4. Given, all right, let's write this back. This is all wrong. I'm just copying back question 3. As you guys can see, nothing has changed. All right, this is given 9 to 3 x squared dx is equal to 234. 10 to 9 x squared dx is equal to 271 over 3, and 9 to 3 x dx is equal to 36. Calculate 10 to 3 4x squared dx. So you want to pick your battle really carefully here, because we're going to go ahead and see what we can do. We don't have 10 to 3 in the given ones, between 10 and 3. So we're going to have to go from 9 to 3, and then from 10 to 9, and that will get us from 10 to 3. Okay, that will get us from 10 to 3. In other words, if you wanted to see what this looks like, this is a part of a parabola, right? Part of a parabola. And we want to go from 3 to 10. But there's no set of values from 3 to 10, so we have to go from 3 to 9, and then from 9 to 10. 2 separate areas. We have values for this. From 9 to 3 is 234, so 4 times 234. And from 10 to 9, oh, by the way, I forgot the constant there, because both have a constant of 4. From 4 to 9 is 4 times 271 over 3. So we have to work a little bit on simplifying this. This is 4 times 234 is 936. And 4 times 271 is 1084 over 3. So 936 over 1 is, if we multiply both numerator and denominator by 3, we get 2808 over 3. So this is 2808 over 3 plus 1084 over 3, which is equal to 3892 over 3. Alternatively, you can use your calculator. If you're not good with fractions, that would be 936 plus 1084 divided by 3, math, fraction, answer, and get the answer directly as 3892 divided by 3. But I'm sure that you guys are taking a higher level math course, and manipulating your fractions would not be a big deal, right? Question 5. Given seven to 4 x squared dx is equal to 93, 8 to 7 x squared dx is equal to 169 over 3, and 7 to 4 x dx is equal to 33 over 3. Calculate integral 7 of 7x minus 7 squared dx. So as you can probably tell by now, this is 0. You can't really calculate anything because this is just no area under the curve. We're not moving from anything to anything. We're just going from 7 to 7. And question 6, given between 5 to 2 of x dx is equal to 10.5, 5 to 2 of x squared dx is equal to 39, and 9 to 5 x squared dx is equal to 604 over 3. Calculate 529 5x squared dx. So we're not given 5 to 9, but we're given 9 to 5. Okay, and we know that this is the negative of 9 to 5. We can put the 5 outside, right? Of x squared dx. So this is negative 5 times 604 over 3, which is negative 3020 over